All right, welcome to completing the square day 1/day 2. We're going to do it all in one day. So watch the first half and then try to do the number ones without the numbers in front, and then watch the second half and try to do the ones with the numbers in front. Okay? So the first thing we need to talk about is what's a perfect square. So perfect squares are numbers that are squared. So 4 is a perfect square, 9 is a perfect square, 16, 25, and you could keep going on. We did these last semester, I believe, too, and we think we went all the way up to 15. If you want to finish these, go ahead. But the whole idea is that we're going to try to get these perfect squares to work with our answers, okay? So the first thing we need to remember is how to FOIL or use the box. So x plus 4 squared is really just multiplying x plus 4 times x plus 4. So I'm going to use the FOIL method, so I get x squared plus 4x plus 4x plus 16. So my final answer is x squared plus 8x plus 16. And then we're going to try the next one, the same method, and then we're going to see if we can do a pattern to make it a little faster. So we're going to cross that out because it's really just the same thing as being multiplied twice. And then we're going to FOIL. So we get x squared plus 3x. And then we get plus 3x plus 9. And your final answer is x squared plus 6x plus 9. All right, so now we need to figure out a pattern. So pause it and see if you can figure out how we get the middle term and how we get the end term. All right, so I hope you figured out that 8 comes from 4 plus 4, and 16 comes from 4 squared, or in other words, 4 times 4. So let's check to see if that works on the second one. 6 comes from 3 plus 3, and 9 comes from 3 squared, or in other words, 3 times 3. Okay, so let's try to do these last three without the shortcut. Go ahead and pause it and see if you can jot these down quickly. All right, so you should get x squared plus 14x plus 49 because 14 is 7 plus 7, 49 is 7 squared. The minus signs are a little different, but pretty much the same. You get x squared minus 8x plus 16 because -4 plus -4 is -8, but -4 squared is positive 16, okay? And then the last one is x squared minus 10x plus 25. Notice this last term is always positive because a negative number squared is still going to be positive, but the middle term is dictated by the sign that's in the middle of those, okay? All right, so now that you see those quick methods, we're going to kind of go into where we don't know what the number is, okay? So we need to work backwards now to figure out what the original perfect square was. So we see 25 and we should think 5 times 5, and 10 is 5 plus 5, so that must have meant the original perfect square was x plus 5 squared, okay? Another way to look at it is half of 10 is 5, and 5 squared is 25. So let's see if that follows. You look at 9 and you think 3 times 3. Half of 6 is 3, so the original number perfect square must have been x plus 3 squared. Okay, and then move on to this last one. Half of 8, -8 is -4. 4 squared is 16, so I think that 4 was the original number. See if you can do these ones on your own now by pausing the video. All right, so half of 14, you always take half of the middle term. So half of 14 is 7, and then 7 squared is 49. Okay, let's go on to this one. Half of 12, or half of -12, excuse me, is a -6, but -6 squared is still a positive 36. All right, and the last one is a little bit tricky, but we're just going to leave it as fractions. Half of 7 is 7 over 2, or if you wanted to use 3.5, that's fine. And then 7 over 2 squared is really the same thing as squaring 7 and squaring 2. If you prefer to use your calculator and square 3.5, that's fine too. But I don't have a calculator on hand, so I'm just going to square the fraction, and I get 49 over 4. And you're only going to run into a couple of those that aren't nice numbers, okay? So the trick you need to remember is half of the middle term and then square it. Half of the middle term and then square it, okay? So now we're going to do one complete problem. The reason we need to complete the square is because our problems aren't going to be perfect. If I were going to take half of 6, I would get 3, and 3 squared is not 11. So I need to make it into a perfect square, okay? So I'm just going to follow the steps. The first step is to write without the y and then move the 11 over. So ultimately you want to just pretend the y is not there and write x squared plus 6x. And we're going to put plus blank because 11 isn't our perfect square. And we're going to move the 11 over to the other side. So in other words, I need to add it. So it's going to become a positive on that side. The next step is to take that and rewrite it as a perfect square. So I'm going to write x squared plus 6x plus blank equals 11. If I add something to this side, I have to add something to this side, okay? So that's why I have to put plus on both sides. So I'm going to put plus blank on this side and plus blank on this side. And now I need to write it as a perfect square because I can only write, if I want to get it into vertex form, I ultimately want my final answer to be x plus something squared and then plus a number because this is going to give me my x coordinate and this is going to give me my y coordinate. I want to get it into vertex form, which is what we worked with last semester. So I'm going to take x, and I know it's going to be a plus sign because of that plus sign. Half of 6 is 3. 3 squared is 9. If I add 9 to this side, I have to add 9 to this side. So I'm left with x plus 3 squared. 11 plus 9 is 20. Okay, and now I pretty much have it in vertex form. I need to write it in this final form, so I'm left with x plus 3 squared. And then in order to get that 20 over to the other side, I'm going to subtract it. So instead of having a plus, I'm going to have minus 20. And now I know that my vertex is negative 3, because it's the opposite inside, remember, and negative 20. So if I go over here, my vertex is negative 3, negative 20. And my original form up here, I know the y-intercept is negative 11. And remember, the x-coordinate is always 0. And then you can make a sketch of that. And what I like to do is just write the point if it's a big number and just write negative 3, negative 20. And then my y-intercept's at negative 11. And then I just like to make a pretty rough sketch of what my parabola looks like. Okay? So the whole point of today is to get it in this final vertex form. And to do that, I need to use a method called completing the square, which is what we just did. So we're going to follow the steps, but they're not written anymore. So I'm going to do one more example and then have you try one on your own. So we're going to rewrite it without the y. And we're going to put that 30 on the other side, which is now going to be negative 30. And the first step is to write plus blank, because I need to make it into a perfect square. And then I know that I want my answer to look like this. And it's going to be a minus because this is a minus. Okay? All right, so first step. Half of the middle term. So half of negative 12 is negative 6. And then negative 6 squared is 36. If I add 36 to this side, I have to add 36 to the other side because that's the only way to make the equation balanced. So I'm left with x minus 6 squared equals 6 because negative 30 plus 6 is 6. And now I pretty much have it in vertex form. The last step is to minus the 6 back over. So I'm left with y equals x minus 6 squared minus 6. And now I know that my vertex is positive 6, negative 6, okay? So this is the form I want to get into. And the whole reason I want to do that is because I want to get my vertex, which is 6, negative 6. If I go back up to my original equation, I know that the y-intercept is at 30. And then you could just make a rough sketch. There's 30. And then my vertex is at 6, negative 6. We'll call that. And then I go like that. Okay. All right. Pause the video and try this one on your own. If you get decimals and you'd rather work with that instead of fractions, please feel free to. All right, first step, write it without the y, put your plus blank, and then we're going to move the 1 over to the other side. So we're going to plus it over. So now it's a positive 1. And remember, we need blanks on both sides to keep the equation balanced. And we're always going to be writing it as a perfect square. It's going to be x plus because we have a plus sign right here. Half of 7 is 7 over 2. And if you prefer to leave it as 3.5, that's fine. And then 7 over 2 squared. You can read that. Oh, gee. 7 over 2 squared is the same thing as just squaring the top and the bottom. So you get 49 over 4. And if I add 49 over 4 to that side, I have to add it to that side, okay? So my final answer is x plus 7 over 2 squared, which is equivalent to 3.5 squared, is equal to 1 plus 49 over 4. So I don't have a calculator in hand. I'll grab one in a second, but I'm going to work with fractions. 1 is equivalent to 4 over 4. Remember, to add fractions, you need a common denominator, so that's 53 over 4. So you could leave it like that, or give me a second, I'll grab. All right, if you prefer not to work with fractions, you can just type 1 plus 49 over 4 in your calculator, and you get 13.25. Again, we're almost to vertex form now. All we have to do is move this over. And our final answer is x plus 3.5 squared minus 13.25. Okay. We now know our vertex is at negative 3.5, comma negative 13.25. So I'm going to go up here and write it. All right, and then if we go back to our original, we know that the y-intercept is at negative 1. So there's my y-intercept, and my vertex is going to be somewhere down here. And then I can draw my sketch in. All right, so that's the first half of the video. Hopefully you got it down with just the number in front. Remember, the steps are half of the middle term, square it, and don't forget to add it to both sides, okay?